So if you're not addicted to making people feel better, then you're going to be addicted to something that's not going to be beneficial to you. And that's just one example, right? When we look at, some of the changes and variations in genes that can affect mood and behavior, you have to understand it's incredible, because what we are doing is looking at variations outside of traditional variations in your DNA, right? So quick science lesson here. All DNA tests are looking for variations in your DNA, changes. Most, I would say 99.9% of DNA tests look at a change or variation known as SNPs, singular nucleotide polymorphisms. What that essentially means is there is a change in the base pair of your DNA. All DNA is made up of 4 base pairs, A, C, G, and T. When C's and G's bind together and A's and T's bind together, sometimes they're reversed, and that causes a change in your DNA. Most of that DNA changes is harmless and doesn't have any impact on your body, but sometimes it does. Now, what happens is there exist variations, and members of our team were actually the first to discover variations in your DNA outside of SNPs. Variations like copy number variations. In other words, the entire gene has been copied and repeated. So you actually have more than one copy of the gene. That can be profound and have a profound impact on your overall health and lifestyle, specifically if we're talking about detoxification or the metabolism and excretion of hormones, right?
And I find you can find a pathway planner that looks at hormone detox or methylation pathways, and knowing someone's genetics and knowing where they might be stuck in that cycle is really, really helpful, instead of just looking at, okay, what is their blood markers or what are their urine markers? Because you can, for instance, if someone's low in progesterone, you can supplement with progesterone if they're low, but if their genetics show that it's aromatizing or even converting to something else really quickly and not clearing, then that could be more of a problem.
Yeah,
so that's
absolutely.
where I really like it.
Yeah, absolutely. So there's two very important things you mentioned. Most functional tests are tests in time, meaning they can be impacted by anything you've done before or after that test. For example, if an individual does a Dutch test, they might feel like their levels of estrogen metabolites are low, but if they had a green smoothie like 24 hours before, that could be impacting the results of their test. When you look at genes, now you're looking at the body's innate ability to produce toxins. So it's not going to be impacted unless you make a decision to change, and epigenetics are involved, and you make a decision to modify genetic expression. That's essentially who you are as an individual. Number two, just as you mentioned, if you are low in progesterone and you take a progesterone supplement, if the reason you're low in progesterone is all of your progesterone is being converted to testosterone, guess what adding more progesterone is going to do? Produce more testosterone. It's a cascade. It's a waterfall. So it doesn't stop at P. It goes from P to T, and then from T to estrogen, and then from estrogen into its byproducts.
Right. So that could have a dramatic impact on how you're going to treat these people based off of, it's using the genetics in combination with everything else, in combination with their story, to really have the best plan possible for these people.
Absolutely, absolutely. So I'd love to sort of dive into some of the things that I've been able to discuss with Dr. Mansour. And just so you know, Dr. Mansour really is the brains behind what we've developed here. I'm lucky to be a Padawan and sit with him and kind of learn from him and understand, how these genes are impacting our daily health and lifestyle. So I had an opportunity to sit with Dr. Mansour and review your specific profile. I have to say, it's a fantastic genetic profile. You are genetically blessed.
Of course it is.
So good on you. It's actually fantastic. I mean, looking at the way you manage pleasure, it is optimal. You don't have any deletions in some of your executive function genes. Your production of BDNF, brain-derived neurotrophic factor, is excellent. So from an executive function profile, you are as great as it comes. So, blessed, you're one of the lucky few. Cardiovascular health. So this is where, it gets a little bit interesting, right? We've all heard about stories of seemingly super fit athletes, guys like Bob Harper, guys like soccer players who in the middle of the pitch, for example, drop dead of a heart attack, right? And you're thinking, well, let's think about an individual's exercise routine, we're looking at, they're eating well, they're at the peak of athletic fitness, why did they have a heart attack? And when we start looking at the genetic factors implicating things like this, we find that there's an actual gene that determines the sensitivity of the inner lining of your blood vessels. Okay? That gene is known as the 9p21 gene. Basically, what happens is if you have a suboptimal version of this gene, your blood vessels are more prone to, they're sensitive, and so they're going to be more prone to inflammation as a result of toxins. Those toxins can be external like smoke, pollution, mold, for example, or any kind of food, inflammatory foods that you're eating. But they can also be affected by internal toxins. Now, how does the body produce internal toxins? Well, you have the hormonal byproducts, such as 4-hydroxyestrogen, but a basic law of physics is whenever there's energy, there's a byproduct. That's why when you burn fire, you get smoke. Fire is good, smoke is bad. In the body, when the body creates energy by breaking down the energy molecule known as ATP, you have byproducts released. Those byproducts are known as reactive oxidative species, oxidants. Oxidants are an internal toxin that inflame the inner lining of your blood vessels. How do you produce a high level of oxidants? High cardiovascular output, like running around a soccer field for 90 minutes at a time. Right? So if you take the example of an average individual like a Jennifer who's 45 years old and is a female executive who's living and working downtown, and her daily mantra is to get out at 7 a.m. and run around the block, first of all, if Jennifer has those sensitive inner linings of her blood vessels and she's running around the pollution of downtown, she could literally be running herself to death. So what we have to do once we understand her genes is then say, hey, Jennifer, number one, probably should be running in a gym instead of running outside. Number two, if you want to run outside, try to go out in the suburbs where there's not as much pollution. And number three, do you really think you should be running to hit those calories? Or perhaps you want to consider weightlifting because the excess cardiovascular output could be putting you at a potential risk. So that's how we can understand cardiovascular health. Not from the typical, well, I'm overweight or I'm obese and I don't eat right, so I have cardiac issues, but from a genetic perspective. No, what have I been given? What is my legacy? And what can I do about it? Again, fantastic cardiovascular profile.
Are you sure I can run? Maybe I should take running off.
You know what? A lot of people try to get that excuse from a genetic perspective. Hey, maybe I don't need to run. In your case, you've got a pretty excellent cardiovascular profile. There could be a little bit of a concern in terms of blood pressure, but as long as you're managing that well with diet, lifestyle, and nutrition, that's really taking care of yourself, you're going to be fine.
Good.
Okay. One of the other systems we really focus on, and this is a little bit of, I would say, a system that not a lot of people talk about. This system is known as methylation. Now, Breanne, if you put me against a wall, put a gun to my head, and you said, describe methylation in one word so everyone gets it, I'd say anti-inflammation. A good methylation profile means you have good anti-inflammatory properties within your body, okay? When you have a poor anti-inflammatory response in the body, that can manifest itself in a number of ways. It can manifest itself in terms of inflammation in the brain, so the neurons aren't able to transfer information because they're inflamed. And then you have concerns like brain fog, like migraines, some children with poor anti-inflammation and poor detoxification. That's one of the potential reasons why individuals are placed on the spectrum. And it's not necessarily a diagnosis for autism. It's a misunderstanding of how toxins are not being removed from the child's body because the detoxification system doesn't work, and the anti-inflammatory response is suboptimal. So if it happens in the muscle and nerve fibers, you get concerns like fibromyalgia, concerns like neuropathy, because the muscle and nerve fibers, there's inflammation, and the information isn't being passed between the nerves and the fibers. Sometimes that inflammation affects you in the gut. So sometimes if you have inflammation in the gut, guess what happens? You're looking at concerns like IBS, inflammatory bowel syndrome. You're looking at Crohn's disease. Methylation plays an impact in every single one of these concerns. So it happens in every cell of our body, and when it's suboptimal, it can manifest itself in a number of ways. Okay. By the way, you have what I would say is a little bit less than average methylation profile. If I were you and I understood my methylation profile really well, what am I looking to do? I'm looking to improve how my body methylates. What is methylation? It is simply the action in the body of transferring methyl groups of carbon and hydrogen from outside of the body and outside of the cell into the cell. Because when methyl groups come into the cell, they activate genes. So if you can imagine, the methylation cycle is a group of engineers in a bus trying to get to a factory to operate the factory. There's a lot of things that can go wrong there. The bus could break down. You put the wrong type of engineers on the bus. The bus didn't get through into the gates of the factory in time. And when the engineers got there, they forgot the manual. Those are all scientific concerns that I described in a very easy way for everyone to understand. But what it means is that we need to identify not only what kind of vitamins we're taking and the type of the vitamin itself. A lot of people take B12, vitamin B12, cyanocobalamin, because they believe it's going to give them energy. Well, guess what? If your body is genetically unable to absorb cyanocobalamin in the gut, all the oral B12 tablets you're taking are useless. It's just passing right through your urine. If your body is unable to convert or unattach methyl groups from your cobalamin, you need a pre-methylated cobalamin product. You need a methyl B12. And if your body cannot absorb it in the gut, you can't even take it orally. You got to take it sublingually, because the capillaries underneath your tongue are going to transport that methyl group and then methyl vitamin B12 directly into your bloodstream where it needs to get. So these are some of the insights we can glean, again, from understanding the entire methylation profile. Does that make sense so far?
And there's even some people that don't tolerate methylcobalamin too well.
Exactly. So methylcobalamin itself, sometimes you have to consider, well, if a person is a very poor methylator overall, you got to consider adenosyl or hydroxy B12, which is a much easier B12 to manage from the body. And the body will do what it needs to do, but you can't overload it, right? It's, you know, in the supplement world, it's not always more is better. It's what's exactly right for me is what's best for me.
Yeah. My patients tell me when I've overloaded them with methylcobalamin.
Yeah, it's not a pleasant experience, I'll tell you that. Okay, so now we get to what I think is the funnest part of the test, right? Diet metabolism. Here's the deal. Ketogenic diet and the ketosis, it's all the rage today. Everyone's got to get on the keto diet. Here's the thing. The ketogenic diet consists of two very important factors. Intermittent fasting, right? Not eating for 16 hours a day and eating for 8 hours a day, whatever it is you pick. And eating an increased fat diet. So, if, you know, avocados, grass-fed dairy, bulletproof coffee, whatever it is you want to call it. What happens is every single one of us has a gene that determines how well we can metabolize fats. And if we can't metabolize fats well enough, there is a known genetic, clinically proven association between fat consumption and weight gain. Straightforward, right? So keto won't necessarily be for everyone, and the way to understand is knowing what genes are determining how you eat. The other cool thing about our test is we can look at an individual's propensity for satiety. Satiety means I feel full. Individuals who are prone to low satiety genetically don't know when to stop eating. The kind of people who walk into a buffet and don't realize they're full until they're on their fourth plate and they can't breathe. That's an actual genetic, there's an actual genetic mutation or a variation in your FTO gene. It's the fat gene, right? It's literally the obesity gene. And what's interesting about this is controlling the genetic markers for obesity and hunger has less to do with what you're eating and more to do with how you're eating. So you want to be able to, and the reason for that is, if you think about sensations in the mouth, you're thinking about, all the senses: bitter, sour, sweet, salty, umami, if you want to consider that. So the mouth is always looking for satisfaction. If you eat one kind of food over and over again, your mouth doesn't realize that you're not going to get the feeling of satisfaction for the rest of the senses you're looking for. So you keep eating because you think eventually it's going to come. That's why people overeat. But if you, for some reason, were able to say, okay, if I know that I have low satiety, I need to satisfy my mouth. So here's a really great example. If I were to take 2 gluten-free crackers, let's say, right, because most people should be gluten-free. If we were to take a good quality cheese, sorry for everyone who's dairy-free out there, but something that's a little bit fatty, whether it's an avocado, let's say an avocado for the guys who are dairy-free, or a good quality cheese like brie, and then I was going to combine that with 2 or 3 sour, green, or red grapes, and I finish it off with a bite of bitter dark chocolate, I'm never going to get hungry again. And that's why the most successful and the best-selling snacks out there are what? They're trail mixes. It's like prana, right? You put Kilimanjaro chocolate in there, and you look at the combination of what you're eating. You've got your nuts, you've got your cranberries, you've got your dark chocolate. So there's a reason for that. It's because those combination of snacks satisfy the mouth's feeling. So it's a snack because it satisfied you until you actually eat again. I know it's a lot of information. I can see the comments. It is a lot of information, but that's why we're here talking about it. And, I'll be available anytime. We can do something weekly, monthly to talk about this in detail as more of your followers sign up and start, using the program. But essentially, just as there's a gene that determines how well an individual is going to metabolize fats, there's a gene that determines how well an individual is going to metabolize starches, right? The person who wants to eat pasta and rice and all that kind of stuff, but has a poor AMY1 gene, which determines how much amylase you make and the effect of that amylase, sorry to say, you should probably not be eating all that pasta and rice and starches, right? You probably want to lay back on those. And generally what we see is an individual who can metabolize fats really well can't metabolize carbs really well, and vice versa.
It's and what was rare. Mine?
So
I'm pretty sure I can do both.